Hello, everybody, and welcome to another visual pattern challenge. Here is step one of our pattern. Here's step two. Here's step three. And your challenge is to figure out how many dots are going to be in step number 4. If you can do that, can you figure out how many would be in step 43? And could you write an equation that could be used to express the number of dots in any step at all? That's the challenge. If you'd like to accept that, pause the video and work it out. All right, so this is an unusual looking pattern. Um, just kind of getting a general impression of the shape. It looks like a sort of circle, although we've got a right angle over here. So sort of circle or rectangle or something with a diagonal. And it looks like the sides and the diagonal are all growing. So I think what I'm going to do is just look at each of the sides and the diagonal and kind of track how much they grow so I can predict step 4. That's what we'll do first. So on the top, we've got these 2 dots, and then it's 3, and then it's 4. So I would think we'd have 5 along the top in the next step. All right, let's look at the left side here. We've got 1 dot, and then 2 dots, and then 3 dots. So I'm guessing this would be 4. And on the bottom, now I've got to be careful here. I don't want to count the corner dot twice. So I've got 3, so I'm counting all of those, and then 4, and then 5. So I should have 6 here. And then we don't want to count that bottom corner dot. So I've got 1, and then 2, and then 3. So this should be 4. And then the diagonal. Well, we've got 1 here, and then 2, and then 3. So this should be 4 for the diagonal. So let's add all that together. 6 and 4 is 10, and 5 is 19, and plus 4 is, that's 23. So my prediction is that there will be 23 dots in step number 4. Now let's analyze these numbers to see what's really going on here. My guess is that this is a linear pattern. It seems to be growing by the same amount. 1 is being added to each of the 4 sides plus the diagonal. But let's just verify that by making a chart with the step number and the number of dots. So in step 1, we've got 3, 4, 5, 6, 7, 8. In step 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep, that's adding 5. And in step 3, 1, 2, 3, and 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then in step 4, we're predicting 23. So let's take the difference between each step. 13 minus 8, that's 5. 18 minus 13, that's 5. And 23 minus 18, that's 5 again. So yes, we're getting a constant in the differences. And this should make sense. We're adding 5 dots every step. So that looks right. Because we have a constant in the differences, we know this is linear. And we can use the equation for a line to model this pattern. And the m, the slope, is going to be the rate of change, how much the pattern grows by each step. So I'm going to write this as y equals 5x. And then the plus b, well, let's actually try out this much of the equation with step 1. So y equals, now y is going to give us the total number of dots. X is the step number, so y equals 5 times 1. And that would be 5, but we have 8. So we actually need to add 3 more. So we can put this for our plus b. It's a 3. And now that should be our whole equation, but let's test it with step number 2. So y equals 5 times 2 plus 3. That'd be 10 plus 3, that's 13. Yeah, that's how many in step 2. How about step 3? Y equals 5 times 3 plus 3. 5 times 3 is 15, 16, 17, 18. Yep, that's how many we got in step 3. So this looks like a good equation. Y equals 5x plus 3. Now, finding the number in step 43, it just requires plugging in 43 for x, where the step number goes. So y equals 5 times 43 plus 3. And let's see, 5 times 40 would be 200, and 5 times 3 would be 15. So that's 215 plus 3 would be 218 dots in step 43. Well, how did that go for you? Did you get 23 for step 4? Did you come up with an equation like this? Let me know. Thanks, everybody.